In hospitals, the way that devices are managed is particularly different, mainly because even though these are, you can call it Internet of Things, some people call it Internet of Medical Things, it's very delicate to, for example, patch a device that is being used in an operation, or try to scan a device, or it's very delicate because you don't want to put the patient's lives on risk. So that's why in many hospitals they use a dedicated software component named Xylera. And this is a particularly interesting technology because it not only detects incidents on the device, but it has a particular way of getting like a clone of the different operating systems that these machines have. And these machines, some of them may be Win 7, Win 10, even Windows XP you find in some of those devices. So managing them, patching them, it is something delicate. And this technology actually kind of clones an image of every one of those devices and scans it separately in order not to affect the performance of the device, and it collects a whole bunch of vulnerability information. But also, this Xylera technology has the capability of sending logs with actually a lot of detail about the devices, more than 300 custom properties, to QReader. And in fact, they even have an app that you can have a Xylera dashboard, but that's beyond the scope of this video. Just to give you an idea of what type of things it can detect from the device, this is the information I found on the documentation for that product. So notice the amount of detail that you can get. Of course, not every log is going to have all these fields, but these are the possible fields of the information that it can send. And notice that there's even vulnerability information there as well. Of course, those individual operating systems also can and do send logs to QReader. So QReader sits in here and it receives logs and possibly flows of all these devices, and then it comes up with what it does best, which is do a good correlation and fire an offense. So we put together this demo to highlight how these things operate, and let's take a look at, for example, this offense. Ryuk malware traffic detected. That's the IP address of the actual device. Altoro is the name of the fictitious hospital, and we can actually see the details of that particular incident. We can even go into advisor and see what is it that advisor has to say. Well, there are some tactics. There's been command and control, and that's expected. If the machine has been hit by ransomware, it's probably encrypted by now. And we can look at the graphic representation that advisor makes out of all these. And we see where everything started, and this is this particular device, and in blue is all the possible connections with other type of bad things that can actually are related to this. So let's get back to the actual offense and take a look at, for example, some of those incidents. This is the SOC person detecting that, okay, something bad happened. He's not going to resolve the issue. He's just going to identify the issue and make sure that this is something really definitely bad. And we can see all those 300 and something events. Let's actually take a look. For example, what are the ones from Xylera? This is the one that we are talking about today. And we can click in here and see the actual detail. Let me actually open the payload, and here we see some of those 300 fields. These are the ones that Xylera got information about it. So he's talking to this destination device 94, and it's a Siemens type of device. Okay, what else can we do with this? So at this particular point, what the SOC operator is going to do is it's going to have that offense escalated to resilient, which is the incident management. There's a workflow. There are some things that need to be done. This is beyond the scope of the SOC operator, who just feels pretty sure that this is a case of Ryu. But what are you going to do? Are you going to re-image the box? Are you going to? Well, these are delicate devices, so this is beyond the scope of the guy who detects, which is using QRadar. This is for the guy who's going to resolve the incident, who's going to handle the incident. So let's actually escalate this offense and send it to resilient. So the incident management person receives an offense that was escalated to him. And by the way, that process of offense escalation can be automated as well. And here's the IP address that we saw for that scanner. Let's actually open it up and see what are the things, the workflow that the system will want him to actually operate on. And notice that there are two tasks that has already been completed. Even when the guy, without doing anything, the system went ahead and did these two things. Once is it collected information about that medical device, stuff like what vulnerabilities has, the model, all this information, and this is from Xylera as an interface with Xylera, so makes API calls and retrieves that information. And it actually goes into QRadar, because when you send an offense to resilient, not all the logs and flows and all the data that QRadar knows about it is there. So it automatically said, well, I'm going to need it. So it went ahead and fetched all that information from the logs into and fed it into that particular incident. So now the first manual step that he needs to do is he needs to determine whether, as we can say in this, reading this particular task, is this that you need to determine whether this is malicious or not. And you need a human behind this, because again, the sensitivity of the device that we are operating mandates that type of care. So he needs to complete all this information. So is this malicious IOC found? Is Ryuk has been confirming here? Well, we don't know. There's definitely vulnerabilities. Again, Xylera shared this information to multiple systems. One of them is resilient, and we will see others as the video progresses. So we see that that IP address that we saw before, that's the Siemens scanner information, all the stuff that was actually retrieved from Xylera, where the location is, and that particular vulnerability needs to be actually fixed. That's probably one of the reasons why the machine was infected. Well, and here we have the data that Resilient retrieved from what advisor saw. All that data that we saw in blue there, well, is actually put in here, and he can actually sort the elements by the toxicity level. So as we see that also, advisor found, koala, trickbot, snatch, other variations that might be relevant in here. So for example, let's say that this particular IP address that it connected to is something that you want to add as an artifact to your particular incident. We need to refresh the screen because some additional data has been allowed, and based on that, the workflow determines, well, you don't even need to answer this task. There's definitely indication that Ryuk is definitely there. Those IP addresses are known to be actually malicious, and he is going to confirm now by saying that this is definitely an incident with illegal actions being taken. He can save that, or he can actually go ahead and complete and close. And this is going to make that task as part of the workflow being actually completed. So, and as we see here, that's the task that we can do. Everything that is here in with asterisk, red asterisk, is mandatory, right? So all this data is actually being, this is an optional task that he can or cannot do. But notice that all of a sudden new tasks automatically popped up and are executed without he doing anything. He just validated that this machine is toast, this machine is fully encrypted. So notice that this task was actually being sent to execute an Ansible work task that basically gets this machine out of the network. This machine is actually toast anyway. We want to minimize the chances of it's spreading the malware around. So automatically, it's that Ansible job is going to get it out of the network. And actually, also, let's actually go back to the work to the whiteboard, because there are other things that needs to happen here. So we just saw that task that was launched for Ansible for removal of the device from the network, but also the Resilient has the capability as an interface with Maximo, which is an asset management system. And the purpose of this video is not an overview on Maximo, but this is the way that devices are managed in large enterprises. There are way too many of them, and so you need a sophisticated asset management tool to work on it. And I just want to point out that also Xylera shared vulnerability data with those two systems. So it is what it found, and that's very unique in the way that that finds the vulnerability of medical devices. These two systems are already aware that that particular MAC address with that scanner is actually has those vulnerabilities. Now, what are the actions that needs to be performed in Maximo? Well, the system already created those work orders. Here we are still in Resilient, and we see that create a work order to reimage the device, okay, and create a work order to find other machines with the same vulnerabilities and have those fixed. Okay, that's interesting. And so that's part of the workflow. The analyst, I mean, this was created already, so the analyst doesn't need to be doesn't have to remember all these things. These things have been not only executed automatically, but this is actually being sent to Maximo. Let's actually log into Maximo to see those. So this is a view of Maximo, and again, you on a large hospital or even a small hospital, you cannot rely on individuals to know what is it that needs to be done. People rotate, and so here in the work orders that Maximo does, and you can see these are way beyond security. This is the way that you manage your assets. We can see that 2 work orders were actually created to deal with this incident that were sent to Resilient into Maximo. And here we see one of those work orders to reimage that particular box. But again, how is this done? Where do he get the source of the image? This is a scanner, this is a medical device. And in here, he will have all the detailed information, what are the steps that he needs to actually do and how to proceed to put this device back into the network. And the 230 is, again, well, Xylera told you about the vulnerabilities of these devices. You know what those assets are. So this work order makes sure that this particular vulnerability is patched in those devices. But again, how you patch on those devices is delicate. It might be that you need to do a request for a device that is working right now, hasn't been infected, has the vulnerability, when is the right time to patch it, and how to do it, and how to proceed with that. Again, all those details is what part of the automation that Maximo allows you to exploit or leverage, I would say, in order to close this incident, because you're going to be getting hit by these type of things. So you need to have all these process automated, so it becomes less disruptive. We can even see here an example of a work order for a vulnerability remediation project. I'm actually entering in it. You know, this is for that type of device scanners and what type of information. And notice that there's a bunch of details that the user may do to document everything that is actually being done. Is there a job plan here? How you execute this task? Let's see if there is one. Yeah, well, there is a process here for, you know, updating the firmware of that particular device, and here are the steps, and you know how to actually do it, and everything is actually documented. And the Maximo has the capability of going back when this process has been completed for this machine and close the incident in Resilient once those actions had been performed. So how does this give you an idea of how things work beyond the world that we normally see, which is the security world? Well, in places like hospital and factories, etc., you need to have more things to deal with the incident, to deal with the assets, than just Curer alone.